Question number 7. This is the last question of this paper. This question is from Newton's laws of motion. Newton's laws of motion. Inclined plane motion. Two particles P and Q of masses 2 kg and 0.25 kg respectively are connected by a light inextensible string that passes over a fixed smooth pulley. This is a pulley and this is smooth pulley. Particle P is on an inclined plane at an angle of 30 degree to the horizontal. This angle is of 30 degree. Particle Q hangs below the pulley. 3 points A, B and C lie on a line of greatest slope of plane. These are 3 points A, B, C on the plane. Uh, Distance AB is 0.8 meter, BC is equal to 1.2 meter. This is AB, this distance is 0.8, BC distance is 1.2 meter. Particle P is released from rest at A. Particle P is released from rest. This means that initial speed will be 0. Released from rest at A with a string taut and slides down the plane. During the motion of P from A to C, Q does not reach the pulley. During the motion, particle Q does not reach the pulley. The part of the plane from A to B is rough. Part of the plane from A to B is rough. This part of the plane is rough. With coefficient of friction 0.3. This is the value of mu. Mu is the coefficient of friction between the plane and P. The part of the plane from B to C is smooth. Part of the plane from B to C is smooth. This means that there is low friction in this part of the plane. Part A of this question is find the acceleration of particle P between A and B. We have to find the acceleration of particle P from A to B. Now we will first we make the diagram again. Smooth pulley, inclined plane, this is a spring, This is particle P, string passing over the smooth pulley. On the other end, there is another particle Q. Masses are given. Particle P mass is 2 kg. Mass of particle Q is 0.25 kg. This angle with the horizontal plane is making angle 30 degree to the horizontal. And now first we will represent all the possible forces acting on this system, on these two particles. There are different forces acting on this system, on these two particles. First we will mention the all possible forces acting on these two particles P and Q. The weight of Q acting vertically downward, that is 0.25 G, and the direction of the tension upward towards the pulley. The direction T is a force, tension its direction is towards pulley, and here the direction of the on this side on particle P, direction of the tension towards pulley. Now weight of particle P is acting vertically downward, vertically downward. This is mg, and now we will resolve this weight uh, of the particle P. We will find two rectangular components, one along the plane and other component will be perpendicular to the plane. So these are the components of weight. This component is along the plane and this component is perpendicular to the plane. Reaction of the plane to this particle P will be upward of the plane. This is the reaction of the plane represented by R. This point is A, this point is A, and this point is B, and this point is C. Distance of AB is 0.8 meter. 0.8 meter, and this distance BC is 1.2 meter. 1.2 meter. Now these components of the weight are will be, since this angle is 30 degree, this angle is also 30 degree. So components are 2G, 2G cos 30 degree, and this component is 2G sine 30 degree. Now we have mentioned all the forces acting on particle P and Q. Now we will use Newton's second law of motion for both particle P and Q to find the equations of motion. For particle P, equation of motion will be for particle P, equation of motion will be, since the direction of the motion is along the plane downward, so 2g sine 30 minus this force T minus mu r because uh, this part AB is rough. So for this motion there will be a frictional force because this part of the plane is rough. Friction, the direction of the friction will be opposite to the motion. Force of friction, that is some small f. We are representing this force of friction by small f. So equation of motion for particle B will be 2g sine 30 degree minus t minus f. F is equal to mu r. So minus mu r is equal to ma. We are using here F is equal to ma. Net force is this is equal to ma. So m is 2 and a we have to find. Now we will find the value of this r. R is the normal reaction. This r will be equal to this component of the weight, so we can find the value of r. R is equal to 2g cos 30 degree, but f is equal to mu r. Now since f is equal to mu r, now we will find f. F is equal to value of mu is given, that is 0.3. So mu is equal to 0.3. So putting here the value of mu 0.3. This is the value of mu and r is this 2g cos 2g cos 30 degree. Now by using calculator we get the value of f, that is 3 under root 3. Now putting here the value of f, mu r is equal to f. The value of mu r we have found, that is 3 under root 3. So after simplifying we get this is equal to 10. 2g cos sine 30 degree is equal to 10. 10 minus t minus mu r, that is 3 under root 3 is equal to ma. Now 10 minus 3 under root 3 will become 4.804. 4.804 minus t is equal to ma. Let this is equation number 1 for reference. Now in the same way for particle P, for particle Q, equation of motion will be for particle Q, equation of motion will be Since the direction of motion is upward of particle q, so T minus mg is equal to ma. Equation of motion of particle q will be T minus mg. M is 0.25 and g is the value of g is 10 meter per second square. So we will write here the force, that is weight of particle q, that is mg. 2.25 into 10, we get 2.5. So we write here T minus 2.5 is equal to ma 0.25 a. Let this is equation number 2 for reference. Now we will solve these two equations simultaneously, and we will get the value of a from here. Now just adding these two equations, minus t and plus t, we are adding these two equations. 4 plus 804 minus 2.5, we get this is equal to 2.304. Right side will be adding these two terms, we get 2.25a. From here we can get the value of a. A will be 2.304 divided by this 2.25. We get finally the value of A is equal to 1.02 meter per second square. This is the value of the acceleration of particle uh, P between A and B. Now for the second part, hence mean above part will be used. Hence find the speed of particle P at C. This is the point C. We have to find the speed of this particle P at this point C. Now for this, first we will find the speed of this particle P. We will find the speed of the particle P at this point B. So from A to B, initial speed is initial speed of the particle P is zero because released from rest, and V we have to find the speed of particle P at V, and S is given, that is 0.8 meter. Distance from A to B point is 0.8 meter. So S is equal to 0.8 meter, and acceleration just we have find, that is 1.02 meter per second square. Now we will use this equation, v square minus u square is equal to 2as. V square initial speed is 0, v square minus 0 is equal to 2as, 2 into 1.02, and s is 0.8 meter. After simplifying, we get the value of v from here. V is equal to 1.277 meter per second. This is the speed of particle. 1.277 is the speed of particle P at B. At this point, at point B, the speed is 1.277 meter per second at point B. Now actually we have to find the speed of P at point C. This is the point C. We have to find the speed of this particle P at point C. Now we will consider the motion from B to C. Now for this from B to C, now we will consider this speed of particle P. Just we have found at B. Now uh, for this distance BC, we are taking the speed of particle P. Just we have found, we are taking this speed as the initial speed of the particle, and this is the final speed at C. Now we are taking this speed 1.277. Just we have found, we are taking this speed as the initial speed for distance AB. Initial speed is equal to 1.277 meter per second. B we have to find at point C. S is given, that is 1.2 meter. Distance from B to C. Distance from B to C is 1.2 meter. This distance is 1.2 meter. And acceleration, we have to find acceleration. What will be the acceleration of the particle P during the motion from B to C? This part of the plane is smooth. No friction from B to C. This part of the plane is smooth. So first we will find the acceleration from B to C. First we will find the acceleration. Now for acceleration from B to C, now we will use again the Newton's second law of motion. 2g sine 30 degree force acting along the plane downward, and the tension towards upward in the opposite direction of the motion along the plane, and is equal to m. M is equal to total mass of particle P and particle Q and P. So we will find the acceleration from B to C. 2g acceleration from B to C. Equation of motion will be 2g sine 30 degree, that is a component of weight acting along the plane downward, minus t, direction of tension upward to the pulley, is equal to ma. M is total mass of particle P and Q2 plus 0.25 A. From here we will find the value of acceleration. After simplifying, we will get this. Uh, now it is very clear that tension is equal to the tension is equal to the weight of particle Q. Tension will be the weight of particle Q, because this tension is due to this weight. So in place of T, we will take the weight of particle Q. So we can write 2g sine 30 is 10 minus T is 0.25 g. The weight of particle Q is equal to, now we are adding these two. This will become 2.25 A. 0.25 g becomes 2.5. 10 minus 2.5 is equal to 2.25 A. From here we get the value of acceleration, that is 7.5 over 2.25, we get this 10 over 3 meter per second here. This is the acceleration uh, of the particle P from B to C. We are writing here acceleration will be 10 over 3 meter per second square. Now we are using this equation v square minus u square is equal to 2 as v square minus u is uh, this. We are taking this speed of p at b. This is the initial speed. So we are taking in this case, this is the initial speed. 1.277 square is equal to 2 as. A is 10 over 3. S is distance is given, that is from B to C, that is 1.2. Now we will calculate it and will get the value of V. V square minus uh, 1.277 square is equal to, calculating the right side, we get this is equal to 8. From here, V square will be 9.631. Now taking square root each side, we get V is equal to 3.10 meters per second. This is the speed of the particle P at point C. Speed of P at C, we have found it 3.10 meter per second. Part B of this question is find the time taken for P particle to travel from A to C. Now we have to find the time taken by this particle P from this point A to C. We have to find the time taken by particle P from A to C. So for this, first we will find the time uh, taken by particle P from A to B. Time, first we find time for particle P from A to B point. Uh, we know that the initial speed of the particle P is at point A is 0 because the release from rest. Distance from A to B is 0.8, and time we have to find acceleration from A to B is 1.02 meter per second square. Already we have found it. Now we will use this equation. S is equal to ut plus 1 over 2 at square. S is 0.8. Initial speed is 0, so this term becomes 0. 1 over 2 A is 1.02 t square. We have to find the value of t. 0.8 is equal to, simplifying we get this 0.51 t square. From here, t square is equal to 0.8 over 0.51. Taking square root each side, we get the value of t is 1.25. Value of t will be, taking square root, we get 1.25 seconds. Now in the same way, we will find the time from B to C. time from uh, point B to C. First, we will find the speed of the particle uh, at B. At B, we have found the speed already. That is 1.277 meter per second. We are taking this as initial speed for the for point B to C. At point B, speed is initial speed is zero. Sorry, initial speed is 1.277 meter per second. Distance from B to C is 1.2 meter. It is given, and the acceleration is 10 over 3 meter per second square. We have found already. Now we again use this equation. S is equal to S is equal to ut plus half at square. Now S distance is 1.2. Initial speed is 1.277 into t plus 1 over 2. Acceleration is 10 over 3 t square. Or now we will simplify it. 1.2 is equal to 1.277 t plus 5. Simplifying this, we get 5 over 5 over 3 t square. Now this is a quadratic equation in t. First we remove this denominator, multiplying the whole equation by this 3. We get this 3.6. To remove this 3 which is in the denominator, appearing in the denominator 5 over 3, to remove this 3, we will multiply each side by 3. So we get 3.6 is equal to 3.831t plus 5t square. Rearranging this equation, we get 5t square plus 3.831t minus 3.6 is equal to 0. Now this is a quadratic equation in T. Now we will use here quadratic formula. Quadratic formula to find the values of time, or we can use the calculator to find the values of T. So we get, after simplifying, we get T is equal to 0.5479. Negative value of t will not be considered because time will never be negative. So time from A to C. This is the time from B to C, and this time is from A to B. So time from A to C will be time. This shows that time from A point to C will be 1.25 plus 0.5479. We get finally the answer 1.80. Correct to three significant figure 1.80 second. This is the answer.